Have you ever stopped for a second and wondered why a day has exactly 24 hours? Why 24? Why not 10? Why not 20? Why not 100? We see those numbers so often that they feel like part of nature itself. 24 hours in a day, 60 minutes in an hour, 60 seconds in a minute. We use them to wake up in the morning, to catch flights, to start school, to go to work, to meet someone, and to decide when one day ends and another begins. But here's the strange part. Nature never created a clock. Earth rotates. The sun appears to cross the sky. Night follows day. But nowhere in nature is there a sign saying, today contains exactly 24 hours. That number is a human convention. And the story of how we arrived at it stretches back thousands of years through ancient Egypt, Babylon, Greek astronomy, mechanical clocks, and eventually the precision technology of the modern world. So, who decided that a day should have 24 hours? The surprising answer is, nobody did it alone. Long before anyone had a wristwatch, humans still had to measure time, but they didn't begin with hours. They began with things they could actually see. The rising and setting of the sun, the changing position of shadows, the phases of the moon, and the movement of stars across the night sky. For early agricultural societies, this wasn't just curiosity. Knowing when seasons changed could mean knowing when to plant, when to harvest, and when important natural events were likely to happen. The sky was humanity's first clock, and one of the civilizations that became especially sophisticated at reading it was ancient Egypt. For the ancient Egyptians, measuring time was deeply connected to everyday life. The Nile shaped their agriculture, the sun shaped their days, and the stars helped them understand the night. Egyptian timekeeping developed gradually over thousands of years. They used devices such as shadow clocks and sundials to follow the movement of the sun. At night, they could observe groups of stars, known as the decans. And this is where our story becomes really interesting. The Egyptians divided the daily cycle into two large parts, 12 hours for the day and 12 hours for the night. Together, 24. But there's an important detail. Their hours were not initially the same as ours. An hour of daylight in summer could be longer than an hour of daylight in winter. The same was true for the night. These were often called seasonal or temporary hours. So imagine looking at an ancient Egyptian clock and seeing 12 divisions. It might look familiar, but the length of each division could change with the season. The number 12 was stable. The length of the hour was not. That is a very different concept from the 60-minute hour we use today. And yet, the idea of dividing the entire day into 24 parts had already become part of ancient Egyptian timekeeping. So why 12? There isn't one simple answer that historians can prove beyond doubt. But 12 was an extremely useful number in ancient measurement. It has many divisors, and dividing something into 12 parts creates several convenient fractions. Half is 6, a third is 4, a quarter is 3, a sixth is 2. This made 12 practical for dividing quantities. The Egyptians also had a 12-part structure for the night based on star groups. So 12 became deeply connected with the way they organized the daily cycle. And once you have 12 parts of daylight and 12 parts of night, you naturally arrive at 24 parts for the complete cycle. But there was still a major problem. Those hours weren't equal. Astronomers eventually needed a better system. As astronomy became more mathematical, simply saying this is the third hour of the night wasn't always precise enough. Astronomers needed to compare observations. They needed measurements that could be used from one season to another. And Greek astronomers inherited and developed knowledge from earlier civilizations, including Babylonian and Egyptian astronomy. One of the most important figures was Hipparchus, a Greek astronomer who lived during the 2nd century BC. Hipparchus worked extensively with astronomical measurements. Ancient astronomers normally divided daylight and nighttime into 12 seasonal hours. But astronomical calculations sometimes required something different, hours. This meant converting the changing seasonal divisions into a constant system. That idea astronomers made measurements. So the concept of equal hours gradually became increasingly important. But there was another civilization whose mathematics would leave an even bigger mark on the clock: Babylon. Thousands of years ago in Mesopotamia, Babylonian scholars developed an extraordinary mathematical tradition, and one of their most important ideas was a number system based on 60. We call it the sexagesimal system, base 60. At first, that might sound strange. Why would anyone choose 60? But mathematically, 60 is incredibly convenient. It can be divided evenly by many smaller numbers: 2, 3, 4, 5, 6, 10, 12, 15, 20, and 30. That makes 60 extremely useful for fractions and measurements. Babylonian astronomers used sophisticated mathematical methods to study the heavens. Their astronomical traditions influenced later Greek astronomy, and eventually, their numerical conventions became part of the way people measured angles and time. This is one of the reasons the number 60 survived for thousands of years. It was simply too useful to disappear. And that brings us to something you use every single day: the 60 minutes in your hour and the 60 seconds in your minute. Here's something important. The ancient Egyptians gave us an early foundation for dividing the daily cycle into 24 parts. But the division of those parts into 60 has a strong connection to Babylonian mathematics. The modern system didn't appear overnight. It developed through centuries of astronomy, mathematics, and scientific tradition. Ancient Greek astronomers adopted mathematical ideas from earlier civilizations. Later scholars preserved and developed them. And eventually, the familiar structure emerged: 24 hours, 60 minutes per hour, 60 seconds per minute. But there was still another problem. How do you build a machine that can actually measure all of this? Because for thousands of years, humans had been measuring time using the sun and stars. Then, we built machines. For most of human history, time was something you observed. You watched the sun, you watched shadows, you watched stars, you listened for bells. But mechanical clocks changed the relationship between humans and time. Instead of asking the sky what time it was, you could build a machine that kept track of time for you. Medieval mechanical clocks began appearing in Europe during the late Middle Ages. They were not as accurate as modern clocks, but they were revolutionary. A clock tower could become a shared reference for an entire community. People could organize work, religious activities, markets, and daily routines around the same signal. Time was becoming standardized. And that would become even more important with the arrival of something that completely changed society: the Industrial Revolution. Before industrialization, being a few minutes late was not always a disaster. But railways changed that, factories changed that, modern cities changed that. When thousands of people needed to coordinate, time had to become much more precise. A train couldn't simply leave around noon. It needed a schedule. Factories needed workers to arrive at specific times. Telegraph networks needed coordinated timing. Scientific experiments needed accurate measurements. And eventually, different cities and countries needed ways to agree on what the time actually was. The clock was no longer just a device for telling you when dinner started. It had become infrastructure. Now here's where things get even stranger. You might think a day is simply Earth rotating once, but there are different ways of defining a day. A sidereal day measures Earth's rotation relative to distant stars. It lasts about 23 hours and 56 minutes. A solar day is based on the sun's apparent position in the sky. And even solar days aren't perfectly identical throughout the year. That's because Earth's orbit isn't a perfect circle, and Earth's axis is tilted. So the apparent motion of the sun varies slightly. Modern clocks therefore use a standardized mean solar day. That's why we can say a conventional day contains 24 hours, even though the actual astronomical motion is more complicated. In other words, the clock on your wall isn't simply copying nature. It's using a carefully defined system that approximates and standardizes Earth's changing motion. For centuries, people measured time using astronomical phenomena, but modern science eventually found something much more precise: atoms. Today, the international definition of the second is based on a specific transition in the cesium-133 atom. That sounds almost impossible compared with the first clocks humans built. Ancient people watched shadows move across stone. Modern scientists measure incredibly precise atomic behavior. And the difference is enormous. An atomic clock can keep time with extraordinary precision. These clocks are not just laboratory curiosities. Precise time is essential for technologies such as satellite navigation. GPS systems depend on extremely accurate timing. Computer networks depend on synchronization. Modern telecommunications depend on precise timing. Financial systems use timestamps. Scientific experiments need precise time measurements. Something as ordinary as checking your phone can depend on a chain of technologies that ultimately traces back to humanity's obsession with measuring the sky. So now we can finally answer the question, why are there 24 hours in a day? Because one person didn't simply wake up thousands of years ago and decide, let's make the day 24 hours. The system evolved. Ancient Egyptians divided the daily cycle into 12 parts of daylight and 12 parts of night. Their early hours were seasonal and could change in length. Astronomers later developed methods for working with equal-length hours. Babylonian mathematics contributed the powerful base 60 system that eventually became deeply connected with the divisions of time. Greek, Islamic, European, and later modern scientists continued developing astronomy, mathematics, and timekeeping. Mechanical clocks made standardized time practical, and modern atomic clocks made it extraordinarily precise. So the 24-hour day isn't the invention of one civilization. It's the result of thousands of years of accumulated knowledge. And maybe the strangest thing about all of this is that we don't think about it anymore. You wake up, and your phone tells you it's 7:30. You look at the time, and you trust it. You don't look at the sun. You don't search for a particular star. You don't calculate Earth's rotation. You simply look at a number on a screen. But behind that tiny number is an enormous history. Ancient Egyptians watching the sky, Babylonian mathematicians writing calculations into clay, Greek astronomers measuring the heavens, medieval clockmakers building machines from gears, scientists developing increasingly precise clocks, and modern laboratories measuring time through atoms. Thousands of years of human curiosity compressed into the tiny clock on your phone. So the next time you look at the time, remember this. Those numbers on your screen aren't as simple as they look. The 24-hour day, the 60-minute hour, and the 60-second minute are the result of thousands of years of observation, mathematics, astronomy, engineering, and human curiosity. We didn't invent time. We invented ways to measure it. And after thousands of years, we're still trying to measure it more precisely. Because perhaps the strangest thing about time is that every second disappears the moment we measure it. This is Strangely Found, and if you want to discover more hidden stories behind the ordinary things we see every day, I'll see you in the next one.